Hey guys, welcome back to our vlog.
Today we're in Hamilton Hall.
Oh shit. Arabhy, how'd you fall so fast?
Let's find out. Physics experiment. Hi, my name is Arabhy.
I'm Manisha.
And I'm Anika. The force of gravity is everlasting as it is always acting upon us and the objects around us. As a result, it is important that we familiarize ourselves with the concept of acceleration and force due to gravity, not only for the purposes of this course, but in everyday life.
It is well known that the force of gravity is what keeps us from floating around and allows us to do all the tasks we are able to do every day. But it is less known what the math behind the force of gravity is.
Today we will be conducting an experiment to prove that the acceleration due to gravity is 9.8 meters per second squared.
So this is our first trial for dropping our ping pong ball, and the distance we measured from the top of the staircase to the bottom of the staircase is 297.5 centimeters, and right now we're going to measure how long it takes from the ball for the ball to drop from the top of the staircase to the bottom of the staircase. So in 3, 2, 1. Okay, so now we're going to be doing our first trial for our foosball, where we're going to be dropping the foosball from the top of the staircase to the bottom of the staircase. 297.5 centimeters is the distance. So in 3, 2, 1.
After conducting 5 trials for each ball, these were the times taken for each respective ball to reach the bottom of the staircase. The average time for the ping pong ball to reach the bottom of the staircase was 0.86 seconds, and the average time for the foosball to reach the bottom of the staircase was 0.81 seconds.
We can use the kinematic equation distance equals the initial velocity multiplied by the average time plus half the acceleration multiplied by the average time squared. By plugging in the values for distance, initial velocity, and the average time calculated, we will be able to isolate for acceleration. Initial velocity will be 0 in every trial because the ball is starting from rest, since we're dropping it vertically downwards. Therefore, the final acceleration for the ping pong ball is 8.04 meters per second squared.
The same equation will be used to determine the acceleration due to gravity acting upon the foosball. The final acceleration for the foosball is 9.07 meters per second squared.
The 2 acceleration values obtained will be averaged out to determine a final value for acceleration due to gravity. We determined this value to be 8.56 meters per second squared. There's a downward force due to gravity acting on all matter on Earth, which exerts an equal and opposite force back on this planet. This is in line with Newton's third law of motion.
Acceleration is the change in velocity over a given period of time. An acceleration of 9.8 meters per second squared is the change in velocity by 9.8 meters per second each second. This acceleration due to gravity is unique to the Earth.
If we rearrange the kinematic equation used in this experiment to find our gravitational acceleration value, we find that we get acceleration equals 2 times the distance over the time squared, which is another way of writing acceleration equals 2 times the velocity over the time, showing that acceleration is the derivative of velocity and the second derivative of displacement, thus the reason why we use this equation.
This is the equation used to calculate the percent error for our obtained acceleration value. Our error was 12.65%.
One reason that our final acceleration value is not 9.8 meters per second squared is due to air resistance, since it is a non-conservative force that would decrease the overall acceleration experienced by the object falling. We would have been closer to 9.8 meters per second squared if we performed our experiment in an isolated system where the object only experienced a gravitational force.
We used a relatively small height, only 2 objects, and 5 time trials to determine average time and average acceleration due to gravity.
Since we're calculating average values, it would be more accurate if we used multiple objects, a taller dropping height, and a greater number of trials for each object.
In conclusion, our final obtained value for the acceleration due to gravity was 8.56 meters per second squared. Thank you!